Welcome back to Miss Powers Teaches Math. We're just going to do a couple examples of using our trig functions to find missing sides of right triangles. And there's a couple different situations we can come up across. So I'm just going to do two. My plan is two examples. Okay, we have it where we're finding a side. That's one example, or where we're finding an angle. Well, here we're given an angle. We're missing the side. X is our side length we're missing. So here, and I think we can maybe make that a little bigger. Why not? And so let's find this missing side. So first I need to know, like, am I using sine, cosine, or tangent, right? Which one will I use to find this missing side? Well, which one will give me an equation? So an equation I can use, right? I need to fill in an equation. I got three pieces, kind of. I got, because what sine of an angle, right? Actually, I should go ahead here. Let's see if we can move these. Oh, nope. It's too smart. It's too, nope. Watch, then that's, okay. All right. Here we go. So we got sine theta, cosine theta, and tangent theta. And I should just say sin of theta. But anyway, so sine of theta. Well, what's sine of theta? It's opposite over hypotenuse. Cosine theta would be adjacent over hypotenuse. And tangent theta is opposite over adjacent. So what we must do is figure out, well, which one of these can we actually plug them all in? Which of these pieces do we have? Do we have opposite and adjacent, opposite and hypotenuse, adjacent, hypotenuse? What do we have? Well, we have, here's my angle, 23. So opposite, there's my opposite side. I have opposite. And I have opposite my right angle, I have the hypotenuse. And then here, I don't have my adjacent. That is missing. So I have opposite, I have hypotenuse. Which one is opposite and hypotenuse? It's sine. Sine is opposite and hypotenuse. So that's the one I'm going to use. Great. So I got sine of theta equals opposite over hypotenuse. And I'm going to plug in my missing pieces. I know theta is 23. Opposite is 43 inches or feet or whatever. Hypotenuse is x. Hypotenuse is my unknown. Then I solve the equation. I know I can, I've done these enough to know that immediately x is going to be 43 over sine 23. And if it helps, just multiply both sides by x and then divide both sides by sine 23. And this is what you get. So this is my answer. That's the exact answer. So if I wanted an exact, I'll just say that's what x is. If we want to get an approximate answer, we go into GeoGebra. And I'm graphing here. We got this part on the side here. It's fine. And let's go ahead and plug it in. What do we have? Oop. We got 43 over sine 23. Oop. Now, when we do that, got to be very, very careful. In any graphing calculator, you're going to have you have to tell it, oh, well, okay, sine, cosine, tangent. What do we put in those functions? We don't just put numbers in. they're angle measures. And we're representing these angle measures as either degrees or radians. And so that's important. Like, hey, is it 23 degrees or 23 radians? Those aren't the same. So it made it real obvious and clear here that this is degrees. It made it degrees, so I could feel confident I did this right. But with whatever calculator you're using, you got to make sure, whoops, what did I do here? I wanted to go open settings. There we go. In basic, and usually it's somewhere it's going to say, hey, are we in degrees or radians? And so let's see here. If you're in this one, there it is, angle unit. So click here, angle unit. It was already in degrees. If I want to do radians, I can put it right there and switch it. So anyway, whatever calculator you're using, make sure you pay attention to that. Very important. So we got the side here. It's going to be about 110.1 if I'm rounding. But I'll just round to the whole number. Yeah, we'll round out tenths. So about 110.1. That's about the length of x. Does that make sense? Well, 23 degrees is the smallest side. Hypotenuse is the largest. 23 is pretty small. This other side would have to be 67, right? That's about 3 times the size of this angle. So this side is probably about 3 times the size of this side. Or maybe not exactly 3, but you get the gist. It's going to be a lot bigger. Yeah, it's a little less than. Anyway. So anyway, the idea is here. Yeah, that's a reasonable size, right? That's reasonable. That's a good answer. I like it. 110.1. Okay, one example done. Let's do one more. All right, here's another example where we're finding an angle. But the idea is the same. I have, what sides do I have? Which trig function am I going to use? I'm going to use, well, I have the opposite of my angle. So I'm going to use whichever trig function uses my opposite and, well, adjacent. Opposite and adjacent. I don't know my hypotenuse. So which trig function is opposite and adjacent? Well, that would be tangent. Just write it down. So tangent of x equals 9, because it's opposite over adjacent, 5.4. So that's nice. The only thing I have to do here to solve for it is undo tangent. And that's the thing you got to remember. Tangent's a function. So we got to do the inverse function of tangent. What's the inverse function of tangent? Well, it's inverse tangent or arctan. Okay? And that's the only thing that you got to remember is I'll just write tangent inverse. So the way we write it is this. Inverse tangent. So I'm going to do inverse tangent of this whole side, and I'm going to do inverse tangent of this whole side, and that will undo it, and I'll have my answer. And it's as easy as that. Whenever we're finding an angle and it's inside a trig function, we got to use the inverse trig function that's associated with it. And it's very easy. So I'll go over those at the end of this quickly. Here, we'll do that very quickly. So right now, let's go ahead. We're doing inverse tangent of 9 over 5.4. So in GeoGebra, in whatever calculator, we're going to use a calculator for this, okay? It is actually easier in a lot of these calculators to start type in an arctan. It's the same thing. Rather than trying, because that whole to the -1, that's the way we like to write it. It's quicker. But arctangent of 9 over 5.4. A lot of these online calculators will just do arctan, arcsine, arccosine. Easy. Those are the inverse functions. So there it is. And we got to make sure, are we in degrees? We already checked that. Yes, we're in degrees. It even said degrees here, which is really nice. It's telling us. And so if it's missing degrees in this calculator, that means it's probably radians. So the angle's about 59 degrees, 59.0 for rounding to tenths. So we get an about 59 degrees. X is exactly, why are you doing this? There we go. Is exactly inverse tangent of 9 over 5.4, and that's around, what did I say? 59 degrees. About 59 degrees. So we could solve for missing angle measures. Very easy. Very easy. And so you need a list of the inverse tangent of the functions, right? So we got tangent, cosine, and sine of x. Their inverses are inverse tangent, inverse cosine, and inverse sine. And another notation of those would be arctan, arcsine, arccosine. They are both used commonly. They're both commonly used. So they're both perfectly fine. With the graphing calculators, online stuff, this one's easier to use. If there's commands, probably do this, because doing the superscript to the -1, lots of times that can mean a power, but here it's not. It's a notation thing. It is not 1 over tangent of x. That's something completely different that I will need to cover with you later. Okay, so it's not that. It is a function that undoes tangent, and tangent undoes inverse tangent, right? They're inverse functions, okay? So that's the important thing to get there. All right, so that's all I got for you. Until next time, enjoy doing math.